So today we are going to start with the second chapter, that is polynomials. Now before I start with the basic definition of polynomials, I would just like to show you the difference between integers and whole numbers. Okay. For example, now just look at this number line. This number line shows us integers. Now how do I define integers? I say integers, they contain positive counting numbers, they contain negative counting numbers, and along with the number 0. These three together combine to give us the set of integers. Now if I say what are positive integers, if I ask you what are positive integers, you will start from 1, 2, 3, 4 and so on. They are known as positive integers. Or what can I call them? I can call them natural numbers. So positive integers or natural numbers mean the same. Similarly, if I say negative integers means -1, -2, -3 and so on. That means 0 is neither included in positive integers nor in negative integers. Now suppose if I say non-negative integers, if I want to write non-negative integers, what will I write? Non-negative means from the set of integers, I just want to remove the negative integers, and negative integers will obviously start from -1, and it means I will remove all these integers. So what are we left with? We are left with 0, 1, 2, 3 and so on. So they are known as non-negative integers. So can you see the difference between positive integers and non-negative integers? They are not the same. There is a difference. In positive integers, we write 1, 2, 3, 4, 5, 6 and so on. Whereas in non-negative integers, we start with the number 0 and then we write 1, 2, 3 and so on. So non-negative integers or whole numbers, they mean the same. So normally this terminology is going to be used many times in this chapter, non-negative integers. So that doesn't mean they are positive integers. Non-negative integers will start from 0, then 1, 2, 3, 4 and so on. And when I say positive integers, it means I am starting from 1, 2, 3, 4. Because 0 doesn't come under positive integers. 0 is separately included. So when I say non-negative integers, it means I just have to remove the negative integers, the negative counting numbers from the set of integers. So I have removed -1, -2, -3 and so on. So what are we left with? 0, 1, 2, 3, 4 and so on. So that is equivalent to whole numbers. That means positive integers are equivalent to natural numbers, whereas non-negative integers are equivalent to whole numbers. Now let us start with the basic definition of polynomials. Polynomials is actually an algebraic expression which contains many terms. When I say poly means many. Poly means many. So an algebraic expression which contains many terms with some special condition. That condition is that the power of the variable should be a non-negative integer. Okay, now I'll write down the general form of a polynomial. The general form of a polynomial is a0 a1x plus a2x square plus a3x to the power 4 plus so on up to an x to the power n. This is known as the general form of a polynomial. Now, what do you observe here? That there are many terms in this expression. In this algebraic expression, we have many terms like n terms, where n is any general term. Okay, if I say n is equal to 2 or 3, That means there are only 3 terms. So I will restrict my polynomial only up to 3 terms like this. If n is equal to 4, I will add one more term to this. Okay, like this. So this is the general form of a polynomial, where what are a0, a1, a2, a3? These are nothing but the real numbers, and they are known as the coefficients. They are the real numbers, they all belong to real numbers, and they are known as the coefficients of various terms. What is the coefficient of the first term? It is a0. Coefficient of the second term is a1. Coefficient of the third term is a2. Next term is a3, and so on. So these are the coefficients. Now just look at the power of the variable. Here the variable involved is x. Look at the power of the variable in this term. Nothing is written, means this power is 1. In this term, the power is 2. In this term, the power is 3, and so on. So that means, and in the first term, there is no power of x available. So if I want, I can write it as x to the power 0, which you all know is actually equal to 1. So the power of the variable starts from 0 here, 0, 1, 2, 3, and so on. That means the power of the variable is a non-negative integer. As I explained you just now, what is a non-negative integer? It is actually a whole number. So I now repeat the definition of a polynomial, that the general form of a polynomial is given by this expression, where the coefficients a0, a1, a2 up to an, they all belongs to real numbers. And what is n? N is a non-negative integer, or in other words, I can also call it whole numbers, where n is a whole number. But normally you will see everywhere this terminology is used, non-negative integer, which I have already explained you, that there is no difference between a non-negative integer and a whole number. So I will say the power of the variable should be a non-negative integer. Now suppose if I ask you 3x square plus 7x plus 5, is it a polynomial? Our answer should be yes. Why? Because first of all, we look at all the coefficients. These coefficients are all real numbers, no problem. Now look at the power of the variable. Where is the variable here? X is the variable. What is the power of x in this term? It is 2. Power of x in the second term is 1. Power of x in the third term, there is no x available here, so I can write it as x to the power 0. It means that the power of the variable in the third term is 0. So what do we have as the powers of the variables? We have all non-negative integers. So we can say yes, it is a polynomial. Now second example, if I write, suppose under root 3 x square plus 7 root x plus 8. Is this a polynomial? You will say no. But then what is the reason for this to be not a polynomial? The reason is not root 3. Here root 3 actually means 3 raised to the power 1 by 2. We are actually not looking at the power of these constant numbers. These are the coefficients. Root 3, 7 and 8, they are just the constant terms, and they should all be real numbers, where we know root 3 is very much a real number. So this is not creating a problem. The main thing which is creating a problem is the second term. In the first term, the power of the variable is 2, it's okay. In the second term, if you see, the power of x is actually 1 by 2. As I told you in the previous chapter, root x or x to the power 1 by 2 is the same thing. So in this case, our second condition, that the power of the variable should be a non-negative integer, is not satisfied here. In the first term, yes, it is a non-negative integer. In the third term, it is x to the power 0, which is also a non-negative integer. But in the second term, the power is not an integer at all. So this is not a polynomial. So I hope you have understood what is the meaning of polynomial and how to recognize whether the given expression is a polynomial or not. Now suppose if I say 7x square plus 5x plus 6. So If I ask you how many terms are there in this expression, you can say there are 3 terms. How do we count the number of terms? How do we count the number of terms here? We will count the number of terms by, like, terms are separated by a plus or a minus sign in between. So 1, 2, 3. There are 3 terms only. On the other hand, if I write 7 into x into y into z plus 5, how many terms are there? You can't say that these are separate terms because they are not separated by a plus or a minus sign. There is all multiplication in between them. If I want, I can write it as 7xyz. 7xyz plus 5. So that means how many terms are there? 1 and 2. So there are 2 terms in this polynomial. Okay. Similarly, if I write, say, 2x minus 5y plus 3z minus 8. Is this a polynomial? Yes. But you must be wondering, in the definition, I used a single variable x, and here I am using so many variables. So that doesn't mean that this is not a polynomial. It is again very much a polynomial, but it is not in one variable. We are going to study only polynomials in one variable in class 9th. Okay, so if somebody asks you, is this a polynomial? You will say, yes, it is a polynomial, but not in one variable. Okay, and how many terms are there? 1, 2, 3 and 4. There are 4 terms in this polynomial. Next thing is, how do we represent a polynomial in short? The way to represent a polynomial is like this. I can write p of x, q of x, rx, fx, gx, hx and so on. Basically, these are the normal notations for a polynomial. So if I want to write a polynomial, I can say px is equal to x square plus 5x plus 6. So instead of again and again saying polynomial x square plus 5x plus 6, if I have already named a polynomial by px, I can say polynomial px. So whenever you do any question on polynomials, first thing is that we should always represent it by some symbol, say px, qx, rx or fx, gx, hx, anything. Okay, already. Now this x, what is this x showing? This is showing the variable which is used in the polynomial. Like in this case, the variable used is x. On the other hand, if I write down a variable as y cube plus 3y square plus 7y plus 6, then I cannot name it as p of x. That will be a wrong notation of this polynomial. So because here the variable used is y, so I will be writing p of y. We call it like this, p of y. Similarly, if I write a variable polynomial as 3z to the power 4 plus 4z cube plus 8. Is it a polynomial? Yes, it is a polynomial, and we will represent it by, say, f of z, because the variable used in this polynomial is z. So we read it as f of z. What is the name of this polynomial? F of z. So this is how we represent the polynomial. This is the general notation of polynomials. Now let us see what is meant by the standard form of a polynomial. Now basically, standard form of a polynomial means either we write down the polynomial in terms of increasing order of power of the variable or in decreasing order of power of the variable. Both ways, if you write, it is known as the standard form of a polynomial. Now look at this polynomial. I'll name this polynomial as px. In this polynomial px, if I want to write down the standard form, I would like to first write down the powers in the decreasing order. That means the highest power first and then we will keep on reducing the power. So in the polynomial px, if you see 5x to the power 4 is carrying the highest power, that is 4. Next term is 8x cube. Next is 6x square. Then we have 3x and the last term is without any x, that is 7. So this is known as the standard form of polynomial px, or I can also write px as 7 plus 3x plus 6x square plus 8x cube plus 5x raised to the power 4. So in the first case I have written the decreasing order of the powers, whereas in the second case I have written the increasing order of powers. The constant term, what is the power of the variable here? There is no x present here, but I can assume it to be x to the power 0. Okay, so this is known as the standard form of a polynomial. Next thing is the degree. What is meant by the degree of a polynomial? Now degree means the highest power of the variable in the given polynomial is known as the degree of a polynomial. Let us look at this polynomial itself. Look at the polynomial px. What is the highest power of the variable? The variable here is x. Highest power of x here is 4, as you can see very easily. So what is the degree? What is the degree of the polynomial px? That is equal to 4, because that is the highest power. If I write another polynomial, say qx, as 8x plus 9x to the power 4 plus 4. Is this a polynomial? Yes. What is the degree of this polynomial? Just go to each and every term and observe the power of the variable. In the first term, the power is 1. Second term, the power is 4. In the third term, the power of the variable is 0. So what is the degree of the polynomial qx? That is the highest power, which is 4 in this case. Now if I ask you, is this polynomial qx in the standard form? No. So how will you write down the standard form of this polynomial? First we write down the highest power, the next power is 1, that is 8x to the power 1, and then 4. Or what is the other way of writing down the standard form? I can write it as 4 plus 8x plus 9x to the power 4. But normally we use the first one, that is in the descending powers of the variable. First we write down the highest power of the variable, then we keep on reducing the powers. This is more commonly we use this form, that is the standard form of a polynomial. Okay. Now let us discuss different types of polynomials. Now polynomials can be divided on the basis of number of terms of the polynomial or the degree of the polynomial. So let us start with dividing the polynomials on the basis of number of terms. Now polynomials can be divided into, you must have heard about these terms earlier, monomial, binomial, trinomial, and so on. Normally, what is a monomial? Monomial is a polynomial having one term only. For example, if I write 3x, it is having only one term, so it is a monomial. If I write only 4, that is also an algebraic expression, so that is also a polynomial. It is known as a constant polynomial. I'll talk about this later. So this is also a monomial. Now what is a binomial? Any algebraic expression having, any polynomial having two unlike terms is known as a binomial. Now why are we using the term unlike terms? Because if I take two terms, say 2x plus 3x, both these are like terms. If I take only two terms without saying unlike word, if I say a polynomial having two terms is known as a binomial, but then because they are the like terms, I can add them up and they will come out to be equal to 5x, which will reduce to a monomial. That is why it is important to say a binomial is a polynomial having two unlike terms. That means 2x plus 3x square. Their variables, the power of the variable should not be same. They are known as unlike terms. So now this is a binomial because it has two unlike terms. They cannot be further added. What is a trinomial? Trinomial is a polynomial having three unlike terms. Again, we are using the word unlike terms so that they cannot be added or subtracted further. Say 7x plus 5x cube plus 8. This is a trinomial. All the three terms are unlike terms, so they cannot be added, or even if there is a minus sign in between, they cannot be subtracted. So three unlike terms, that is known as a trinomial. So on the basis of number of terms, we can divide the polynomial as monomial, binomial, trinomial, and if there are more than three terms, we call it a polynomial, and if they are more than three terms, say 4, 5, 6, we can call it by the number of terms, like polynomial with 4 terms, polynomial with 5 terms, polynomial with 6 terms, and so on. The special names are given to first three: one term monomial, two terms binomial, three terms trinomial. Next is, we divide polynomials on the basis of degree. Now degree, you have understood what is the meaning of degree? Okay. Now the first kind of a polynomial is having a degree 0. If the degree of the polynomial is 0, what do we call it? We call that polynomial as a constant polynomial. For example, if I take 8, can I call it a polynomial? Yes, it is very much a polynomial because I can write this as 8 into x to the power 0. I mean, 8 can be written as 8 into 1, and in place of 1 I can write x to the power 0. This you have already studied in exponents. So any constant number can be written as any variable raised to the power 0. So can I call it a polynomial with degree 0? Actually, what is 8x to the power 0? It is 8 only. That is why it is known as a constant polynomial. So any polynomial whose degree is 0 is called a constant polynomial. Second is, if the degree of the polynomial is 1, what do we call it? For example, 2x plus 5. If I take a polynomial and the degree here is 1, as you can see, the degree is 1, this is known as a linear polynomial. Any polynomial whose degree is 1 is known as a linear polynomial. Now, what is the general form of a linear polynomial? I can write it as ax plus b. This is the general form of a linear polynomial where a and b are nothing but real numbers, any real number. They can be in fraction, they can be negative, they can be positive, they can be with irrational numbers also, because I said real numbers. Real numbers include both rational as well as irrational. So a and b can be anything, but with a special condition on a, that it can be any other real number, but a cannot be equal to 0. What will happen if a will become 0? Then polynomial px will reduce to 0 into x plus b, that is only b, which will be a constant polynomial. This is no more a linear polynomial. So whenever we define the general form, we specify that the coefficient of this highest degree term should be not equal to 0. Third is, if I say the degree of a polynomial is equal to 2, then what do we call it? Suppose I say x square plus 5x plus 6. This is known as a quadratic polynomial. Again, if I want to write down the general form of this quadratic polynomial, I will write it as ax square plus bx plus c, where what are a, b and c? They are all real numbers, but what is the condition on a? It can be any other real number, but it cannot be equal to 0, because the moment coefficient of x square will reduce to 0, this term will vanish and will be left with only a linear polynomial. On the other hand, if a is not 0 but suppose b is 0, it will still remain a quadratic polynomial. Or suppose if c becomes 0, then again it will still be a quadratic polynomial, because the term containing the highest power, that is x square, that is still intact with us. So that is why we call it a quadratic polynomial. The degree is 2, it is known as a quadratic polynomial, and this is the general form. Now next is, if the degree of the polynomial is equal to 3, then we name that polynomial as a cubic polynomial. For example, say px is equal to x cube plus 2x square plus 5x plus 7. This is known as a cubic polynomial because the highest power here is 3. We call it a cubic polynomial. Now the general form of a cubic polynomial can be written as ax cube plus bx square plus cx plus d, where what are a, b, c and d? They are any real numbers, but the condition on a is that it should not be equal to 0. The same thing as I explained to you in the earlier one, that b, c or d can be 0, but a cannot be equal to 0, because if a will reduce to 0, then this term will vanish and we will be left with only a quadratic polynomial. That is why the general form is ax cube plus bx square plus cx plus d, where a should not be equal to 0. It can be any other real number, but it should not be equal to 0, whereas b, c and d can be equal to 0 as well. Okay. Next is, if the degree is equal to 4, then the polynomial is known as a biquadratic polynomial. Biquadratic. When the degree was 2, we used to call it quadratic polynomial. When the degree is 4, we call it a biquadratic polynomial. For example, any expression having degree 4, even if I take this is also a biquadratic polynomial, because here the degree is 4, or it can have any number of terms, but highest power should be 4. Then the general form of a biquadratic polynomial is ax to the power 4 plus bx cube cx square plus dx plus e, where what are a, b, c, d, e? They are all real numbers with the condition that a will not be equal to 0. If a will become 0, then this term will vanish and it will reduce to a cubic polynomial only. On the other hand, b, c, d or e can be 0. Even if all of them are 0, no problem, because ax to the power 4 will still remain, and then it will be a biquadratic polynomial. Okay.